Hi everyone and welcome to this tutorial on using reverse calculations to check answers. So in this tutorial we're going to be looking at how to reverse different calculations where they're looking at what's the opposite of adding, what's the opposite of multiplying. Okay, so let's start with an example. Let's think about if I had 4 add 3 equals 7, okay, what could be a reverse of this calculation? Well, the reverse of this calculation is either 7 take away 3 equals 4 or 7 take away 4 equals 3. So what we can do is we can always check our calculations are correct by reversing them in this way. Now, if I was to represent this with pictures, what I could think about is if I had 4 things here and 3 things here, we can see that collectively this makes 7. And if I then remove 3 of them, I'm left with 4. Or if I chose to remove 4 of them, I'm left with 3. So this is what this question is saying. If I know that 4 combined with 3 makes 7, I know that 7 when we remove 3 is 4, and 7 when we remove 4 is 3. Okay, right. What I want to do is I want to think about this reverse calculation again now, but maybe when we have a different makeup of numbers. So one of the main things I really want to get you to understand is that everything in maths, no matter how long the calculation, just makes up a number, okay? So, and that, when we understand that, that really helps things fall into place. So let's say instead of having 4 plus 3 equals 7, what I had was 8 divided by 2 plus 3 equals 7. Well, what I can say with this is that 7 take away 8 divided by 2 equals 3, and 7 take away 3 equals 8 divided by 2. Okay, so here we go. We have just used a reverse calculation in a different way. Right, so this here is an example of reverse calculation for adding and subtracting. Let's now look at if we start with a subtraction. So let's say this time I'm starting with 10 take away 3 equals 7. So let's think about that as a picture. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm going to take away 3 of them. So here we go, I'm going to get these 3 and then I'm going to move them over here. So here we go. I've now done 10 take away 3 and I can see that there is 7 here, because we still have 1, 2, 3, 4, 5, 6, 7. So now what I know though is I can see if I combine these two things here, this thing that I just took away, I can see that 7 and 3 make 10. So I can write that there. But I could also write that 10 take away 7 is equal to 3. So these things are all reverse calculations for adding and subtracting. Okay, right. Let's take a quick look at reverse calculations for multiplying and dividing, and then we'll move on to some of the questions that are on the sheet. So let's this time consider we have a calculation of 2 times 5 equals 10. Okay, so if I have 2 times 5 equals 10, what I'm talking about here is I have got 2 lots of 5. So here we see we've got 2 lots of 5. So we've got 2 lots of 5 equals 10. And then the reverse calculation of this is I can do 10 divided by 2 equals 5, which we can already see here because we've got the 10 split into the 2 groups. Okay, but what we could also do is we could also do the 10 divided by 5 equals 2. And we could see that here because we could have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we can have 5 groups of 2. So this is how we've got the reverse calculation here. Now, what is important to notice here is the pattern in how we rearrange these as well, because obviously we're not going to be drawing out these diagrams all the time, but we have to notice here that it's the result of multiplying the 2 numbers together, which we call the product, which is the number that we can then divide by the other 2. So do you see here that the 10 is the product, and the product is what goes here and here. So we say this 10 divided by 2 is 5, 10 divided by 5 is 2. So the product, which is the result of multiplying the two numbers together, always goes first. Okay, so let's have a look at this one more time like this, and then another time when we're starting with a divide. Okay, so let's say this time we've got, I don't know, let's go for a decimal number. So if we do 3.7 times 2.4, and from the calculator I know that this equals 8.88, we can identify 8.88 as our product. So if I want to rearrange this expression, what I know is that the two numbers that multiply together to give the product, when we're doing the division, we need to put the product first, okay? So 8.88 divided by 3.7 will equal 2.4, and 8.88 divided by 2.4 will equal 3.7. So remember, the product always goes first in the reverse calculation for multiply and divide. Now, let's have a look at this when we get a question like this. Okay, so here we see 18 divided by 3 equals 6. So remember, this line here means divide, and I could always rewrite this if I wanted to as 18 divided by 3 equals 6. Now, before we do our rearrangement to check, what we need to think about is we need to think about which one of these numbers is the product. Well, the product is always either the result from multiplying the two numbers together or the number that is being divided by. So in this case, 18 is our product, okay? So if we've got here 18 divided by 3 equals 6, we know that 6 times 3 equals 18, or 18 divided by 6 equals 3, okay? So remember, the product always goes first in the division. So it's always a case of spotting where is the product. Let's try one more and then we'll go on to the questions from Crack Maths. So let's say this time I've got 16.1 divided by 4.6 equals 3.5. Okay, so how can I do a reverse calculation to check this? So remember, the first thing is we need to identify our product. So our product in this case is the 16.1, which means that 4.6 times 3.5 is going to equal 16.1. So that is one of the reverse calculations we can check. So we can check 3.5 times 4.6, and that should equal 16.1. But I can check that on my calculator. So let's have a look. 3.5 times 4.6. Yep, and that is correct. And we can also rearrange this to be 16.1 divided by 3.5, and that should equal 4.6. Okay, and again, you can check that on your calculator. 16.1 divided by 3.5, and that equals 4.6. Okay, so they are how we do reverse calculations. So let's now go to the questions on Crack Maths and have a go at a couple from the practice and a go at a couple from the scenario. Okay, so I'm going to look at question 1 first, and question 1 says, check that 14 plus 6 equals 20 using subtraction. So this was the result, so the result is going to go first. So I'm going to do 20 take away 14, and what I should find is that this equals 6. So I can do that on my calculator. So 20 take away 14, and yes, I can conclude that that equals 6. But I could have also done 20 take away 6, and that should equal 14 as well. So I will just check that again. So 20 take away 6. Yep, and that does equal 14. Okay, so that is question 1 done. Let's have a look at question 2. Okay, and here we go. Question 2 says, check that 63 divided by 9 equals 7 using multiplication. So remember, we need to identify our product. So the product is the number that's first in the division or the result of multiplying the two numbers together. So in this case, the product is going to be the 63. So if this calculation is correct, 9 times 7 should equal 63. So we should be able to do 9 times 7 and find out that that equals 63. And I actually do know that that equals 63, so I can tell that that is correct. Okay, there's a few algebra questions here, and I just want to have a look at a couple of them just before we move on to the scenario questions, just because it's useful to tap in with that so that we can see how this is applicable regardless of if it's regular numbers or if it's a missing number. Okay, so question 5 says, solve x divided by 2 equals 8 and check your answer with multiplication. Okay, so again, this is a division one, so multiply and divide comes together. And remember, we're always looking for the product. So something divided by something equals something else. It's the thing that's being divided is going to be the product, and that will equal the other two things multiplied together. So let's have a look at this. We've got x is our product. So if x divided by 2 equals 8, we know that x divided by 8 equals 2. And we also know that 8 times 2 will equal x. Okay, so 8 times 2 is 16. So if this is true, the missing number, which they've used x to represent, will be 16. And now let's check that that works. So we could have 16 divided by 8 equals 2, which I know is true. And we could have 16 divided by 2 equals 8. So that's true as well. So actually, it would make a lot of sense if this number was 16, because we know that that is true. So we have actually solved that equation by using our reverse calculation method. Okay, right, let's look at one more question from the practice and then we'll go over to the scenario. Okay, so here we go. We have got, in this question, if 4x equals 36, find x and check your answer. If you see a number next to a letter, that does mean that they are being multiplied together. So if I've got 4x equals 36, what that means is we've got 4 times x, where x is just a number, equals 36. So what I can identify from this is that the product in this scenario here is 36, which means that 36 divided by 4 will equal x, and 36 divided by x will equal 4. Now, the one of these that is most useful for us for being able to find out what x is going to be this, because 36 divided by 4 will give us an answer. So you might know it from your times tables, or you can work it out in the calculator if you're allowed it. But I know that 36 divided by 4 is 9, and I can check this a multitude of ways. I could say, well, I'm just going to highlight here, so that means that x equals 9, just so that we know that. That is the answer that they want. But now let's check it by putting 9 back into here. So if I remove this x and replace it with a 9, 4 times 9 equals 36. Yes, that's true. So I have just checked this answer, and we can confirm that x is equal to 9. Okay, let's now have a look at some of the scenario questions. Okay, so here we go. We've got question 1 from the scenario questions. And question 1 says, Emma paid £48 for 6 tickets. She calculated each ticket cost £8. How can she check her answer? Okay, right. So what we know is that we know that in this scenario, the number of tickets times the price will equal the total that she paid. Okay. Now from the question, I can see that the total cost we knew was the £48, and the number of tickets that she bought was 6. Okay, the price is what she calculated, so I'm just going to put price here for the time being. Okay, so if we've got this here, we've got two things multiplying together to give a product. Okay, so 48 is our product. So if 48 is our product, we know that 48 divided by the price will equal 6. And 48 divided by the 6 should equal the price, okay? So we've got a couple of ways here which we can test her calculation. So because the price was the missing thing, let's first of all confirm her calculation was correct, where we can assume that she did 48 divided by 6, okay? Now, you might know the answer to this, or you can do it on your calculator if you're allowed your calculator, but 48 divided by 6 will give us £8. So we can confirm from our calculation that she is correct, but they want to know how can she check her answer. So what she could do is she could do 6 times 8 and check that that gives 48, and it actually does, because 6 times 8 is 48. So she's got it. Yeah, well done, Emma. You calculated your ticket prices correctly. Okay, let's have a look at one more question from here, and then we will call it a day. So question 4 from the scenario questions says that Ben subtracts £27 from his balance of £100 and says that he has £73 left. How can we verify this? So we know his calculation, which we can write down to start off with. So we have 100 take away 27 equals 73. So if we have 100 take away 27 equals 73, the way that we can verify this is by doing the 73 add the 27, or the 100 take away the 73. So let's first of all try the 27 add the 73. Okay, I'm going to check this on my calculator, and he is correct. So yep, that is a good verification. But remember, the other verification that he could have done would have been to do 100 take away 73, and that does equal 27. Okay, great, and that's that. So well done, and if you want any more work on this, remember that there is plenty of stuff to do at crackmaths.co.uk, and this was tutorial 72. Okay, so long.